Okay, so we're back from watching Kelsey Houston Edwards' video. What are some things that you learned in that video?
It's not possible. It's probably not possible to do it.
Probably not possible. Okay, what else?
I learned what normal numbers are.
Normal numbers. Okay, what are they?
They're numbers where each digit is equally likely to occur.
Okay. A normal number is where each digit is equally likely to occur.
And each sequence of digits is equally likely to occur as well.
Okay, and what was important for purposes of this video? What was important about normal numbers?
Well, if pi and e are both normal, then it is possible to prove that it's not. I don't think it would be possible. It's possible to prove that it would not be possible.
Okay, so that was Terry Tao's argument. Now, the interesting thing is in the last video, we wrote down a couple of numbers. 0. We did ones and then pi.
Yeah.
It's easier for me to just write pi in later. 3, 1, 4, 1, and 0 point blank 1, blank 1, blank 1, blank 1. 3, 1, 4, 1. Can you tell me, are these numbers normal numbers?
I don't know.
Why not?
Because the number 1 occurs more often than any other number.
High five. Very good. So Terry Tao said if pi and e are normal, you can't do it. But we did it. But notice, even though we didn't know what normal numbers were at the time, our numbers were not normal.
Yeah.
Did you know you were not normal?
No.
Oh, okay. So, all right, so that's cool. Normal numbers. What else? What else did you learn from Kelsey Houston Edwards' video?
Well, this is kind of how it's a cool problem.
Oh, you learned it's a cool problem. Yeah. Why? What made it cool?
Well, it was kind of, when it got asked online, it was kind of an introduction of how mathematicians did research.
Yeah. All right. Do you have anything else?
Mm-mm.
All right. What did you think about the video then?
It was pretty neat.
Pretty neat. Okay. There's one thing that came up in the video. I'll probably extend one video longer that came up, saying that if you exchange the digits, you produced uncountably many numbers. So pi is 3.1415992. E is 2.718281.
Yeah.
And do you know what countable and uncountable infinity are? We've talked about it a little bit, but you might not remember.
I think countable infinity is like what you would get if you counted infinitely for an infinite amount of time.
Okay, so countable infinity is the smallest infinity, and
uncountable is anything larger.
Well, not quite anything. So countable infinity is like the integers, the even numbers. Even, by the way, the rational numbers, which is pretty amazing. We've talked about that, but it's probably not the first thing in your mind. It turns out that the real numbers, all the real numbers, rather than just the ones that can be written as a fraction, are a larger set. They can't be paired up. You can't write them down one at a time. And that, well, for purposes of this video, I'll call that uncountable infinity. It's a larger infinity. And so what Joel David Hampkins was saying is if you swap infinitely many digits,
yep,
you can do it in so many different ways that you'll actually produce an uncountable number of numbers.
Whoa.
Which is pretty amazing.
Yeah. Yep.
And she challenged people to try to prove that. And I'm going to show you how to prove that.
Okay.